Name the parts of the micrometer screw gauge labeled as A, B, C, D. In figure 1, we can identify parts A, main scale or sleeve, B, circular scale or rotating scale, C, thimble, D, thimble head or ratchet. I will write it. A, main scale or sleeve. Especially you have to remember this name. Sometimes they will not give marks for main scale, sleeve. B, rotating scale. Or you can write circular scale. But perfect answer is rotating scale. C, thimble. D, ratchet. Ratchet or thimble head. Part B, 1. What is the least count of the above micrometer screw gauge in millimeters? We can identify least count of main scale by using given diagram. It is like this: 0, 0.5, 1, 1.5, 2, 2.5. There are small parts in this side. Therefore, pitch is 0.5 millimeters. And we can identify there are 50 parts in the rotating scale. You can identify after 45, 46, 47, 48, 49. Then again 0, it means there are 50 parts. Then we can write the equation for least count. Least count for the micrometer screw gauge is pitch divided by number of rotating scale parts. Rotating scale parts. Pitch 0.5 divided by number of rotating scale parts 50. Then we can obtain answer is 0.01 millimeters. In part 2, write down the scale reading for the diameter of the ball shown in figure 1. Right. We have to consider the reading in figure 1. When getting reading, we can write reading equals main scale reading plus least count into coincided circular scale part. Main scale reading is 6 millimeters. We can observe 5, 6 and then we can identify circular disc, circular scale like this. Then main scale reading is 6 plus least count 0.01 coincided circular scale part. When getting coincided circular scale part, we have to count it: 45, 46, 47, 48. 48 part is coincided. 45, 46, 47, 48 coincided. 49, then 0 is in this place. Then we can simplify it: 6.48 millimeters. Part 3, figure 2 shows the situation in which the micrometer screw gauge is adjusted to determine the zero error. State the correct value of the diameter of the ball in millimeters. When finding correct value, first of all we have to find the zeroth error. Now we have to observe figure 2. In figure 2, 0 mark is not given. It means 0 mark is covered with this circular scale, rotating scale. Therefore, we have to get the corresponding zero error should add to the reading. Then zeroth error is least count into 50 minus coincided rotating scale part. We have to get 50 minus value because of we can't see zero mark. Right. Least count is 0.01. 50 minus coincided mark in figure 2, 45, 46, 47. Then we can simplify it, 0.03 millimeters. It is zeroth error. We have to add this error to the reading to obtain the correct reading. Then we can write, therefore, correct reading 6.48 plus 0.03. It is 6.51 millimeters. This one is the corrected reading. In part 4, B part 4, write down the fractional error of the measurement of the diameter of the ball. Numerical simplification is not necessary. We have obtained two values for the diameter. First one is 6.48. It is reading, not the corrected value. Second one is 6.51. It is corrected value. We have to remember that when finding percentage error or fractional error, we have to use the value obtained by the instrument, not corrected value. Then we can write least count fractional error equals to least count divided by reading. You have to remember that this one is reading, not the corrected reading. Least count is 0.01, reading 6.51. I will not simplify it. Then part 5. What is the precaution taken in the micrometer screw gauge to avoid overpressing the object? Then we can consider, we can write directly the name of the mechanism, ratchet mechanism. Ratchet mechanism. Or you can describe it. Ratchet mechanism means when rotating instrument by using thimble head, it will rotate freely with the tick tick sound after touching the sphere. Then part C, a wire of circular cross section, length approximately 55 centimeters and diameter D1 4 millimeters is fixed to a disc. Diameter D2 and thickness 3. Approximate values are given, diameter 5 centimeters and thickness 3 millimeters as shown in the figure 3. Magnitudes given in partners are approximate values. Part 1 of the measuring instrument, meter ruler, spirometer, vernier caliper and micrometer screw gauge. Write down most suitable instrument for the measurement of each of the above quantities. We have to write corresponding instruments. L means length of the wire. It is approximately 55 centimeters. We can get 10 centimeters or more than 10 centimeters values by using meter ruler. we know that the condition is percentage error should be 1% or less than 1%. Therefore, for the meter ruler, we can obtain 1% percentage error when measuring 10 centimeters. Therefore, 10 centimeters or more than 10 centimeters lengths are measuring by using meter ruler. Then D1. D1 is the diameter of wire. It is approximately 4 millimeters. It is a small value. Therefore, we have to use micrometer screw gauge. There is a low percentage error for the micrometer screw gauge because of there is a small least count, and there is another benefit. If you are using a measuring instrument like vernier caliper, the shape of wire will change like this when using external jaws to measure diameter. Therefore, correct instrument is micrometer screw gauge. D1 is the diameter, D2 is the diameter of given disc. You have to observe diagram, I will not draw it. D2 is approximately 5 centimeters. We can use vernier caliper to measure D2. You can remember smallest lengths we can measure by using corresponding instruments to obtain the 1% or less than 1% percentage error. T is the thickness. Thickness is a small value, 3 millimeters. Therefore, we have to use again micrometer screw gauge. Part 2. What experimental procedure would you follow to obtain better value for the thickness of the disc? We can obtain several readings for the thickness with different places. Get several readings in different places. And calculate the mean or average. Then part D, the thickness of a certain type of polythene sheet is much smaller than least count of the micrometer screw gauge. Propose a method to estimate the thickness of sheet using micrometer screw gauge. We can fold the sheet. Fold the sheet to obtain a suitable thickness. And then we can measure thickness of folded sheet. Measure the thickness, and finally we can divide the answer, the measurement, by using folded number. By using folded number of times. If they have given a bundle of sheets, we can measure thickness of bundle of sheet, and we can divide number of sheets. We can divide by number of sheets, but now they have given only one sheet. Therefore, we can't use that method. We have to fold the corresponding sheet, and then we have to calculate the thickness of sheet by using number of folded times.